arcs. In this activity, you will investigate the relationships among central angles and intercept letters. The color wheel is made of 3 different kinds of colors: primary, secondary, and tertiary. Primary colors, red, blue, and yellow, are the colors you start with. You create secondary colors, orange, green, and purple, by mixing 2 primary colors. You create tertiary colors, red, orange, yellow, green, blue, purple, red, purple, by mixing a primary color with a secondary color.
Okay, shit. Look like I'm on a art class. So here's the activity. Anybody to read the activity? Yeah.
Consider circles to be shown. The points shown on the circle are equidistant from each other. Draw 2 congruent chords using any of the adjacent points on the circle as endpoints. Draw 4 radii by connecting the endpoints of each chord with the center circle.
Okay, so the first thing you guys have to notice is the fact that they are equidistant from each other, if you know what that means. And then I'm gonna give you guys like a minute so you could create your chords. You have tools. One like straight edge, the compass. I mean the protractor, the straight edge. Yeah. They want 2 congruent chords. And you know the points are equidistant from each other. The points along the circle, the equidistant from each other.
Draw 2 congruent chords, but
Any conjectures you guys have? Dylan.
that all of their legs are congruent.
All the what?
All of their legs are congruent, like GC.
You mean the legs of a central angle?
Yes.
What makes you say that?
Because they're radii.
Okay, so the radii of the same circle and all radii of the same circle are congruent, so the legs of the central angles are congruent. What else? Any other conjectures you could make? No more conjectures? Any other conjecture? It's like a given. It says, it appears that when 2 chords of the same circle or congruent circles are congruent, the corresponding arcs are congruent. Anybody noticing that? Or no? We're going to prove that conjecture. So we're just going to go right ahead and prove the conjecture. So the good news that I have for you today is that the proofs in this lesson in the second day of this lesson are a lot easier than the ones we did yesterday. So they're going to get shorter and easier. So that's a good thing. So I'm going to give you guys a few minutes. You can only talk to people on your table. You can only talk to people on your table. So try to figure out a way for you to prove that arc CH is congruent to arc RD. So if you guys are given that in circle O, line segment CH is congruent to line segment DR, if line segment CH is congruent to line segment DR, can you guys prove that arc CH is congruent to arc DR? Yes, no, maybe, and how? No, so we could possibly if you want, and then we can start again once we have. And keep in mind that on the test, no, you're good, John. Keep in mind that on your test, Friday, you guys are going to be asked to do either a paragraph proof or 2-column proof on something. So getting the idea on proof is it's like a really good practice for your test on Friday. You have on the given, John, you don't have the given. You don't have the markings on the figure for the given, because I believe you're done. There you go.
Oh, he's better. You got it.
John, check the information that you have, because I feel like you're good to go with the two triangles.
What?
Don't you have a 3 sides on one congruent to the 3 sides on the other?
Yeah.
Yeah. Oh.
I think you have SSS already.
I'll put that. Why did you?
We don't need, as long as we get it done, then that's fine.
Wait, yes, hypotenuse level.
There's no right triangles in the diagram for you.
Wait.
So that's what I say about the markings on the figure. So if you guys have the markings on the figure, then you probably notice that you already have the 3 sides of one triangle congruent to the 3 sides of another triangle. So you have them by the SSS.
Whoops.
I don't even know what's the line this time. Oh, we're way back. It's the loops. They still long proofs though. They still long proofs.
Can I just do something to you, please?
I think we're missing something, right? What's that? Yep. Add the step. You're good, John. You're really good. We're just gonna add the step between the CP. I like that you call out those angles by CP. So we have now that the central angles are congruent, but Aiden has one more set. You could add it to the board. So you can just, if you want to erase the last line, so erase number 5. You can erase number 5, and then we can just add that information. Don't lose me, guys. Don't lose me.
Okay, where you at?
The noise in the hallways is enough. So yeah, so now we're at that stage where we have that two of those central angles are congruent by CPCPC. So you know that COH is congruent to angle ROD.
I don't think I got enough space.
You do
Okay.
if you write it small. I mean, if it's like that, it's not gonna fit.
You backing it up. Sorry, bro.
Why you put your hand like that?
You might, I'm alone.
You know?
I don't know who wants to do a little recap. You want to do a little recap or?
Like, recap as in okay. So, what we were trying to solve is
It's your work.
okay. So, number one is given, right? And since these points are on the circle, that means that they're all, like, when you make a line segment between those points to the center, they would all be radii. So then they would all be congruent. And then if you make like a triangle with like these points, right? Then you could already conclude that they're congruent by SSS, because all their sides are congruent. And by CPCTC, you can already say that this angle right here, wait, you could say that these angles right here are congruent to each other, right? And then with what Aiden proved, you could say that this angle is congruent to this arc right here. And the same thing with here. And then by transitive property, we can prove that these arcs are congruent.
Okay. Questions? Questions for John? Questions for Aiden? Anything that you guys are not really getting on proof? We good? Okay. Beautiful. Thank you, John and Aiden. So, because we proved that relation, we could refer to it now as a theorem. So that's going to be our last one. So obviously I have to make an anchor chart for that. It's not there yet. So that's the congruent chord, congruent arc theorem. Anybody wants to read that theorem?
Congruent chord, congruent arc theorem. If two chords of the same circle are congruent, then their corresponding chords are congruent.
Okay. Alright, so the last proof, and I promise you this is going to be the last proof of this lesson. So the last proof that I have for you is the converse of this theorem. So the converse of a theorem, so since it's written as a conditional statement, how do I come up with the converse of this theorem? Anybody know this? Hey.
Flipping the if and then statements.
Okay, so now we are going from the arcs to the chords. Now you guys are given that the arcs are congruent. So how can you use information about the arcs being congruent to prove that line segment CH is congruent to line segment DR? Once again, we're going to pause the video. We're going to take about 2 minutes so you can work with your groups. You're live now, man.
What? You're live.
Since
Chord CH is congruent to chord DR.
yeah, this is given.
Yeah, give.
And you're reading off the board.
So that's an arc, right?
That's measurement of arc CH.
And then that's congruent to measurement of the angle COH by central angle converse theorem. And measurement of arc RD is congruent to measurement of angle ROD by central angle converse theorem. And then The measurement of angle COH is congruent to measurement of angle ROD by transitive property. And then
Line segment CO.
you have line segment CO is congruent to line segment DO by radii of the circle. Then line segment HO is congruent to line segment RO by radii of the circle. Then triangle HOC is congruent to triangle ROD by SAS. And then line segment CH is congruent to line segment DR by CPC.
Alright, good. Thank you. Let me get, so I'm just gonna put this over here. For the common sense. So make sure you guys have everything down, so all your statements and reason, so you can pull it out first. Everybody good with this? As you go, if you do the markings on the figure, that's gonna simplify the work a lot. Alright, so that's why we learn the markings in the first place, so we can do it on the figure. Any questions on the proof? Any questions for Angel? Because I feel like we're getting to the closing activity for this lesson. Alright, so we're going to go to the last session of this lesson, so thanks God with day 2. Last session, it's about your broken plate activity. So, Hillary's reading.
Broken plate. You have investigated and proved several chord theorems and their converses. You can now write each theorem and its converse together as a biconditional statement.
Alright, big word, biconditional statement. Anybody remembers what biconditional statements are? Biconditional statements. What are biconditional statements? We know what conditional statements are, but what are biconditional statements?
There are two conditional statements that group together.
Say it again?
There are two conditional statements together.
What do you mean by two conditional statements grouped together? Huh? What's that?
The converse.
What about the converse?
The converse is true.
The converse is true. Is a conditional statement true? So conditional statement is true. The converse of a conditional statement is also true, so that is biconditional statement. So anybody remembers what kind of statements are the biconditional statement? What type of statement? Do you know what the conditional statement is? What type of statement? How do you know that a statement is written as a conditional statement? Is there anything on a statement that tells you I'm a conditional statement? If and then. What does that stand for? The if part of your statement is the hypothesis of your statement. The then part of your statement is the conclusion of your statement. So I have a conditional statement written in the form if and then. How do I come up with the converse of that statement? I think Aiden said something like about that earlier.
Switch the if and then.
Yeah, you switch the if and then, you switch the hypothesis and conclusion of your statement, and now you write the converse of your statement. So what we said in the past is what happens when the conditional statement is true and the converse of a conditional statement is also true. Your statement becomes a biconditional statement. Anybody knows what type of statement is that? How do we read it? If and only if, right? So it's an if and only if stop now type of statement. So you guys will write the 3 core theorems that we learned in today's lesson as biconditional statement. But before you leave me, I'm gonna make you go through the same stress that Sarah went at some point when she got home. So here is how we're gonna do this. I'm gonna break you guys are into 5 different groups. I'm gonna have 5 pieces of large pieces of broken plates. You guys have the same tools that Sarah had, and you guys now have the same knowledge that Sarah had on her geometry class. So here's a piece of broken plate. 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 And here's another piece of broken plate. Okay, so 412. hear me out, 412. So I did record the dimensions. I did record the dimensions of your 5 broken plates. What I want you to do is, using what you learned in lesson 3, I want you to be able to reconstruct the plate, so you'll be able to tell me when I'm purchasing these plates, what will be the diameter of my plates. Huh? It's not. Okay, cool.